In this tutorial, you will learn how to build a PDF chat application using technologies like Spring Boot, LangChain4J, and AstraDB. So first, let's understand what is LangChain4J. LangChain4J is a Java framework that is used to interact with large language models, also called as LLMs, like OpenAI GPT-3 or GPT-4. By this time you may be aware of what is ChatGPT. So these large language models like OpenAI GPT-3 or GPT-4 are the ones which are powering the ChatGPT application. So in a nutshell, an LLM is a machine learning model that is trained on a variety of data and is able to generate human-like responses and answer our questions. So as I mentioned, ChatGPT is powered by the LLMs like OpenAI GPT-3 or GPT-4. So now let's talk about the architecture of the application we are going to build, and step by step I will explain you the new terms and terminologies which you are going to encounter in this tutorial. And by the end of this tutorial, you will be able to create your own applications, your own AI applications, which are powered by LangChain4J and Spring Boot with the help of AstraDB. So here we have our PDF application, our PDF document, which acts as a knowledge base. And this PDF document is ingested by our PDF assistant application. And what our PDF assistant application will do is it will read all the text which is inside the PDF, and using something called as a document splitter. This is a component which is part of LangChain4J. We will have a look at it later in the tutorial while writing the code. So using this document splitter, what it will do is it will split the text into multiple text segments. Right, you can see that text segment 1, 2, 3, so on until we have multiple text segments. The document splitter is responsible to split the text into multiple text segments. Then we have something called as embeddings. So these text segments will be converting into something called as an embedding. So what really is an embedding? So let's understand what is an embedding. An embedding is nothing but a numeric representation of human readable text. This is also known as a vector. So a vector, to define it further, is nothing but a list of coordinates. So these coordinates are similar to coordinates which are available on a map, right? So for example, if you want to pinpoint a particular location on a map, you do this using coordinates, right? So similarly, when you want to convert a human readable text into a machine readable, machine understandable format, we use something called as, we convert it into something called as a vector. So this vector is nothing but a list of floating point numbers. As you can see here, the term cat can be translated to the floating some random numbers like 0.2, 0.9 and minus 0.75. See that these are some random numbers. I made it up. So you can now get the idea, right? So each human readable text will be converted into this list of floating point numbers. These are called as vectors, which are understandable by the machine learning models. So the next question is, why do we need to create these embeddings? Why can't we just provide the human readable text segments, and why can't we provide this human readable text to the machine learning models? Because we need to create these embeddings because these are necessary so that the machine learning models like OpenAI GPT-3 or GPT-4 can understand this text and then process this text effectively. Because these machine learning models are built on huge amount of data, they need to be converted into a different form like vector form to be able to process the text efficiently. So that's why we need to create the embeddings. The next question is, how do we actually create these embeddings from the text we have, right? So that is responsible by something called as an embedding model. An embedding model is nothing but, again, the large language models like OpenAI GPT-3, GPT-4 and Google BERT, which are responsible to convert the human readable text to the numeric representation. So whatever representation of cat you saw here is generated by the embedding model, that is OpenAI GPT-3 or GPT-4 in this case. We also have many embedding models which are supported. We will also have a look at some of them in the coding part, but on a high level you need to understand that embeddings are nothing but numeric representation of the human readable text, and embedding models are something which are responsible to create the embeddings out of the human readable text. So Next, we have the term called as embedding store, which is nothing also called as a vector store, as a vector database. So these embedding stores are used for efficient storage and retrieval of embeddings. So one of the examples is the Astra DB database, which is based on Cassandra. Astra DB is also kindly sponsoring this video. So Astra DB is a NoSQL and vector database that are mainly used in generative AI applications. And if you're working with applications which needs high scalability, you can use Astra DB. And the interesting thing here is Astra DB is powered by Apache Cassandra. If you are aware of Apache, so if you're not aware of Apache Cassandra, it's an open source NoSQL database that is used to manage massive amounts of data. So you can see that it is a distributed NoSQL database which is trusted by thousands of companies for scalability and high availability. So many fast moving startups and highly distributed applications are using Apache Cassandra, and this is one of the most famous NoSQL database that is used. You can see many of its features, like it provides masterless architecture, and it also supports low latency, and it's also fault tolerant, and it provides high performance, distributed and scalable database. We will see how to work. So we'll see how to work with Astra DB in the later parts of the video. So now let's go ahead into the architecture diagram. So as we saw before, we have the text embeddings. So we left at the part where we are creating text embeddings from the text segments. So we have this embeddings, and now we will store these embeddings inside the vector database that is going to be Astra DB. So this is one phase of the application use case where we take the PDF, convert it into embeddings and store them in the vector database. The next part comes where the user wants to query the PDF. So the user will send some queries to our PDF assistant application. You can see this here in this diagram. So the user is going to ask queries to the PDF assistant application, and what our application will do is it will convert this human readable text format in the query into the query embedding, right? And by converting it into the query embedding, we can now search for the relevant text inside the vector database. So our vector database will provide the results based on the semantic search functionality, and all the results which are embeddings which are coming as a result from the vector database, we will provide them to a chat language model. So why we need to provide this chat language model is the embeddings, as I said before, are machine readable format, which is not understandable by the humans. So we need some functionality to convert these embeddings back into the human readable format, right? So for this reason, we will use a chat language model like OpenAI GPT-3 or GPT-4, which ChatGPT is also using. So by providing these embeddings to this OpenAI GPT-3 or GPT-4, we can get the response back in a human readable format, right? And this response will send it back to the user, so the user will get the answer to the query. All right, so that's it with the theory part. So now let's go ahead with the coding. So I'm in the description section, you can find the link to the GitHub repository. The name of the GitHub repository is LangChain4J PDF Assistant, and you can go ahead and download this code either by using GitHub clone, or either by downloading the zip. After downloading the source code and opening it in your favorite IDE, the next step is to create your account in OpenAI, because we'll be using the OpenAI large language model in our PDF chat application. So I already have an account with OpenAI. So when you open the website openai.com, just click on login, and if you already have an account, it will directly ask you to either select the ChatGPT or API functionality. As I need to access the OpenAI API, I'm going to click on API here, and it automatically logged me into my account. If you don't have an account, you will have the onboarding functionality. You will get onboarded, and once your account creation is done, you can go to the API keys section to the left side, and you need to create a new API key so that our PDF chat application can call the OpenAI GPT-3 or GPT-4 API. right? So I've already created my my API key here. So all you need to do is click on create new secret key and provide a name, and then you will be able to copy this secret key, and please make sure to keep it secure, and note down the API key, because we'll be needing this in the latest part of the video. And after that, the one thing you need to keep in mind is if you go to the usage section, when you newly create your account, you will be given a $5 credit, and if you can use this $5 to play around with OpenAI APIs and see what is actually it's providing, what are its benefits. And once you consume this $5, you need to add more money to be able to access the API. Next, we have the Astra DB in the datastacks.com website. So for that you need to go to, next we have Astra DB. For that you need to go to the website datastacks.com, and under the datastacks.com go to the products and click on Astra DB, and here you can see some introduction about Astra DB. So now I'm going to go ahead and sign into the Astra DB DataStacks portal, and this will take me to the sign-in screen. If you if you're coming here for the first time, you need to click on sign up. This will take you to the sign up page, where you can either register yourself with by providing the details like first name, last name and email, or you can directly sign up using the GitHub or Google authentication. So as I already have my account, I'm just going to go ahead and sign in with Google. So after sign in, you can see that you are greeted in the dashboard of the AstraDB portal, and here you can see that you can have multiple examples and guides about how to work with the AstraDB with LangChain. And here you have the quick access section, and here you can create a database. In our instance, in our case, this will be a vector database. So I'm going to click on a create database button, and here we have to provide a database name. For the database name, I'm going to provide the name as PDF Assistant, and the key space is nothing but a schema. So you can see if I hover over the information icon, you can see that a key space stores your group of tables like a schema in a relational database. This helps keep related tables of information in a single place within your database. So the key space name, I'm going to provide it as PDF Assistant. And you can also select the provider, as this is a serverless vector database. So you can select the cloud provider. By default, it's using Amazon Web Services. You can also select Google Cloud as a provider, and in the country you can select the US East 1 as the default region for Google Cloud. So once this is done, you can click on create database, and then it will go ahead and create the database in the background. So now you can see that the database is in the state pending, and we have something called as a database ID, which we can copy this and we will use this later. And you can see that under the regions, our database is using Google Cloud in the North America region in the US East 1. And this database is under the key space PDF Assistant. We also have different tabs here called health, where we can use the health metrics and performance of our database. We have the connect section, where it has some information about how to connect to this particular PDF Assistant database we just created. It has different information about how to connect using different APIs by using different drivers in various programming languages like Java, Python, C++, C# and Go. So you can explore this if you're interested, and you can also have the look at the SDK option. We have the option to interact with the DataStacks AstraDB database using the Java SDK. This is also one of the options we have. We will not use this Java SDK. We will not use any of these options, because as we are using LangChain4J, it provides very good interaction with DataStacks AstraDB. So we'll be going with that option. So after a few minutes, if you refresh the application, so if you refresh the page, you can see that our PDF Assistant database is in the state active. So to be able to connect to this particular database, we need to create a token so that our application will interact with this database using LangChain4J. So for that you need to go to the connect tab, and here you need to first get an application token so that you can securely connect to the Astra database. So under the drop down, I'm going to select the role of administrator user. As this is a demo, I'm just going to provide the administrator user privileges here, and I'm going to click on generate token, and this provides some token details. Here you can copy the token information, and you can also download the token details. Once you have the token details, we will use this later in the coding section. So now let's go ahead and dive into the code and see how we are going to implement this PDF chat application using Spring Boot, LangChain4J and AstraDB. So now I opened the source code inside IntelliJ IDEA for the PDF assistant application. So now let's go through the application. The first thing we're going to do is to open the pom.xml file. So this is where all the dependencies of our application are defined. You can see that we are using the version 3.2.1 of Spring Boot, which is the latest version as of creating this video, and we are using Java 21. We have the dependencies for Spring Boot Starter Web, and the next dependency we have is LangChain4J, which is the main framework which we use to create our PDF assistant application that interacts with the large language model like OpenAI GPT-3. And we are also going to have a dependency LangChain4J OpenAI to enable the integrations with OpenAI itself. Next we have the dependencies for LangChain4J Embeddings all mini LM L6 v2. So this is an embedding model which we will discuss a bit more in detail once we look at the source code. The next dependency is going to be LangChain4J document parser Apache PDF box. So this dependency is used to read the PDF document and split the text of the PDF document into multiple text segments. So this is the dependencies which is used to do this functionality. Next we have the LangChain4J Cassandra dependency that provides integration with LangChain that provides integration with the Cassandra and AstraDB through LangChain4J. And next we have the dependencies for Lombok and the Spring Boot Starter test. Now let's go ahead into the Java classes. So for that I'm going to expand the source main Java folder, and here we have the PDF assistant application, which is a normal Spring Boot application. We will come into the code in a little bit. First we will cover the class called as PDF assistant config. So this is nothing but a normal Spring Boot configuration class, and here we have a bunch of beans. So let's go through these beans one by one. The first one is going to be a bean about embedding model. So we have defined a method called as embedding model. Inside this method we are creating a new object for the class all mini LML6 v2 embedding model. So this is one of the example of the embedding model which we have talked before, which is responsible to create embeddings from the human readable text. So if I go inside this class, you can read the description that sentence transformers all mini LM L6 v2 embedding model runs within your Java applications process. So you don't need to contact some external embedding models. By using this embedding model, you can create embeddings from the text by using from within your application. So it also has some details like embedding dimensions 384. One point I did not mention in the previous presentation is the concept of embedding dimensions. So if you take this example of a string called as cat, the vector representation of this cat is we saw before as an example called 0.2, 0.9 and minus 0.75. And here you can see that there are 3 elements inside this list. That means this cat text is represented in 3 dimensions, right? By using this all mini LML6 v2 embedding model, we can create the embeddings in 384 dimensions. So this example we saw is with 3 dimensions, but we can create an embedding up to 384 dimensions, right? So this is what the embedding dimensions mean. If we use some other embedding models like the OpenAI embedding model, you can find that by going into this abstract in process embedding model class, and if we go to the embedding model interface, you can see that this embedding model represents a model that can convert a given text into an embedding, right? So if I look for the implementations here, I find this OpenAI embedding model, which is nothing but an embedding model which is calling OpenAI client by using the OpenAI key. So when we use this OpenAI embedding model, the embedding which is created, it contains 1536 dimensions. So this 1536 dimensions, and what we are creating right now with this embedding model, this L6V2 embedding model, is going to be 384 dimensions, right? So this is all about the embedding model bean. I hope it's understandable for you. Next we have the bean for the AstraDB embedding store. So we have created the bean name AstraDB embedding store, and inside this method we are creating object for the AstraDB embedding store using the builder method by providing the token which we have copied in the previous section of the video, the Astra token, and also the database ID which we have copied in the previous section. So I'm going to provide the token and the database ID here, and the database region we previously selected as US East 1, and the key space is going to be PDF assistant. It's not demo table, so I'm going to type PDF assistant, and the table is going to be some table name, some random table name. So I'm going to type PDF chat. So this is going to be name of the table. And lastly, we have the field called dimensions. So this is important because we need to provide the dimensions value, the same dimension value which our embedding model supports. So as we are using this all-mini LML 6 V2 embedding model, and as this supports 384 dimensions, we also have to provide the value for the dimension as 384. So the next bean we have is going to be the embedding store ingester. So this embedding store ingester will take the references about the document splitter. So it contains the references of how we have to split the document. So it contains reference to the document splitters dot recursive function, where it takes max 300 characters. That means whenever this document splitter will read the PDF document, it will take 300 text characters chunks, and it will split for every 300 characters, right? And next we have to provide the embedding model as a reference. So I'm just going to pass in the embedding model as a reference, and also I have to provide the embedding store as the reference. So I'm going to provide the AstraDB embedding store as the reference. So you can use this embedding store ingester later while reading the PDF document. So we will use this in the later parts of the video. And finally, we have the bean for conversational retrieval chain. So this is the place where it will read the embeddings from the embedding data store, and it will call the chat language model. We saw this in the previous part of the video in the architecture diagram. So let's go ahead and check this one more time. So we are back in the architecture diagram. So you saw that whenever the user queries the PDF assistant, it will create the query embeddings, and it will find the relevant text from the vector database and passes it to the chat language model. And the chat language model will provide us the human readable response, right? So all this is being done in the conversational retrieval chain method here. So conversational retrieval chain bean here. So we are providing the reference to the chat language model. So here we are going to provide a reference to OpenAI chat model class with API key, and we have to provide the API key of OpenAI here, so that the conversation, so that LangChain4J will call this chat language model with the embedding details. And we also need to provide the reference to the retriever. So this embedding store retriever.from will use the AstraDB embedding store and the embedding model. So whenever the user asks a query, we will make use of the conversational retrieval chain object to retrieve the embedding and then call the chat language model to get the answer. So now let's go to the PDF assistant application, and here you can see that this is just a normal Spring Boot application, and inside the post construct block in the init method, we are loading the document cassandra.pdf. So under the source main resources, so this is the cassandra.pdf. This is the white paper of Apache Cassandra. So if I just open it, you can see that it is a white paper which is published about Cassandra. So we are going to take this white paper as a reference, and we are going to ask questions to get information from this PDF document. After loading this document, we have to define a bean of type embedding store ingester. So this is the bean we have created in the configuration class for the embedding store ingester. We have provided the reference to the document splitter, embedding model, and the embedding store. So if we just call the ingest method and provide the document, what this will do is it will we can go inside and see what is happening inside this method. So this embedding store ingester is coming from the LangChain4J. So we can just go ahead and deep dive what is happening. If I go inside the ingest method, you can see that if it first splits the document based on the document splitter, and after that it creates the embeddings by using the embedding model.embed all method, and then we receive all the list of embeddings, and after getting the embeddings, it is adding this embeddings to the embedding store. So this embedding store is nothing but the Astra DB embedding store we have created. So this Astra DB, so the ingester is actually adding the documents to the Astra DB at this phase. So once this block of code is executed, then we can be sure that our application has read the text inside this PDF, and it stored it inside our Astra DB vector database. So the next part is to actually query the Astra DB with the human readable questions, right? So for that, I'm created a new class called as chat controller. So this is nothing but a very simple Spring Boot REST controller. We have the REST controller annotation, the request mapping annotation with the request mapping path as /API/chat. And here we are going to inject the conversational retrieval chain object. So, and inside this chat with PDF post mapping method, we are taking a request body, which is nothing but a string, which contains the questions about which is asked by the user, and we are passing this string to the execute method of the conversational retrieval chain. So all we need to do is pass this our query inside the execute method, and behind the scenes LangChain4J will do all these things which we saw inside the architecture diagram. So it will create the query embeddings, it will find the relevant text from the vector database, and after getting the results, it will call the chat language model with all the embeddings, and the chat language model will return us the human readable text as a response. So that's all we need to do to create our PDF application, our PDF assistant application. So now let's go ahead and test this functionality. I'm going to go to the PDF assistant application and click on debug. I already have the application up and running, so I'm just to click on stop and rerun. So you can see that for the very first time, it's going to initialize the Astra DB client. It's going to provide us the database ID, and it also has to provide information about the region where we are created the database, and it's also initiated some calls using the client, Astra DB client, and it also has created the table PDF chat and also created some vectors information here. And once this is done, our application is started successfully. So now let's go to some API client, and inside Postman I'm going to create a post request to HTTP localhost 8080/API/chat, and as a request body I'm going to provide the query as what is Cassandra, and I'm going to click on send. So let's see what is the response our application is going to send. And you can see here that Cassandra is a distributed database management system that is designed to handle large amounts of data across multiple servers. It is designed to provide high availability and scalability, allowing for seamless expansion as data volume increases. So you can see that it provides some quite a useful and quite a comprehensive introduction about what is Cassandra. So in this way you can create interactive PDF based applications using LangChain4J, Cassandra and Spring Boot